Okay, so this is starting off with number 53. We have triangle XYZ with vertices X at, and they gave us 3 different points, right? Then, oh yes, also club day, or not club day, but club picture. Anybody in this period have a club card? It will not let you in unless you have a club card. So, anybody have a club card for this period? We go take a picture for the club. No? All right, moving on. 53. So we got these coordinates. It says it is dilated by a scale factor of 0.25. That's the same thing as multiplying by 1/4. Again, we multiply by a scale factor. So that piece of information is important. That means we're taking the XY coordinates that they give us, and we're going to say 0.25 times X and 0.25 times Y. Then it says it's rotated 90 degrees clockwise, which again, 90 degrees clockwise is the same thing as going 270 degrees counterclockwise. So our rule for 270 is going to be switch the X and Y, and the original X becomes negative. So those are the 2 things that we have to do to each of those points. Now, do we have to do all the points? No. They gave us 3 points. If we just pick one of the points, they're all in the same quadrant to start off, and they're all going to end up in the same quadrant to end this problem. So just pick one of them. We have X is at 4/8. Great. So first thing, multiply by 0.25. So that's going to be 1, 2. Then switch them and make the X value, the original X, negative. So that's now X double prime will be at 2, -1. What quadrant is that in? Okay, quadrants start here. That's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So 2, -1. 2, -1, somewhere about there. That's in quadrant 4. That's our answer. D. Now, are there other ways you can do that problem? Yes. If you wanted to draw a diagram first on your paper, so again, remember, you will have scratch paper, so you can draw on your scratch paper. I could draw that graph. The first thing they had was a dilation. Is dilation changing what quadrant it's in? No, it's going to still be in the same quadrant. So if it started off in quadrant 1, which is what this did, then on my paper, draw my thing. So it'd be like up here. Then I rotate it 90 degrees clockwise. What quadrant is it in now? If it's down here, it'd be quadrant 4. So again, there are easy ways to do this without following the rules by drawing some of these diagrams. Don't forget, you can draw it out and figure out that way as well. You can do that with a lot of these transformation problems. All right, number 54. They gave you the original, they gave you the new. So the original photograph was 4/8. They said that there's a scale factor of 1/4. So multiply by that scale factor. 4 times 1/4 is 1. 8 times 1/4 is 2. These are 2 new dimensions, 2 and 1, or 1 and 2. Questions on either of those? All right, then let's go on to the back. Not back, I'm sorry. The next page. So now, on 55, prove that triangle ABC is congruent to triangle DEF. Do we have to do every single point? No, not really. Start with 1 point. Try this with 1 point. And then if there's more than one that works with that 1 point, then try other points. But for this one, if you do it with 1 point, just start off with A and see if we can get it to the correct coordinate for D. And truthfully, that's all we need to do, because there's only one up here that works for A in order to correctly move it over to D. So if I follow the rules that they gave me, I started off at 3, 1. The first thing that they had me do on this one was switch them and negate the original X value. Yeah, that's not good. So we have negative, sorry, not negative yet. It was 1, -3. All right. The next one, we are taking this and changing the sign of our y value. So that negative 3 now becomes a positive 3. Is that where we have the coordinate for D? No, so it doesn't work. Try the next one. So again, starting back at 3, 1. First step, it says, is negative x, y. So we're changing the sign of x, y staying the same. Then it says we're switching them and changing the sign of the original x. So now we have 1. The x becomes positive again. Again, still not at the right place. It's not where D is. So that doesn't work. Try the next one. This one says subtract 4 from y. So again, starting at 3, 1. Subtract 4 from x. We're now at negative 1, 1. Then it says subtract 6 from y. So we're at negative 1, negative 5. That's not where D is either. That doesn't work. We're already down to the last option, so D must be our answer, but let's try it. So 3, 1 is our starting point. Switch them and make the original y negative. So negative 1, 3. This one then says make the y value negative. So negative 1, negative 3. That is D up here at the top. So D is our correct answer there. On 56, we have our triangles. Again, you can just go through them one at a time, see which one works. I'm just starting at the top. On this one, it says reflect over x and then reflect over y. So let's try it. Here's A, reflect over x. Brings us here, reflect over y, brings us to D. Hey, the first point matches up. So we should keep trying it. If that first point didn't match up, then we shouldn't keep going. Right? So we could have crossed it off, but since it matched up, check the next point. So we have B reflected over the x, so 3 up. We're going 6 over, so 6 over. It matches up with E. So 2 of the points match up. Let's try the last one. C, currently 6 points under the axis. We have 6 points above. 1 point over from this axis, 1 point over. All 3 points matched up. So we had our triangle reflected across the x, then reflected across the y. It worked for all 3 points. That is our solution. No reason to even try the rest. All right. On the next one, 57. Oh, that's not the right thing. All right. On this one, so now we're talking about symmetry. They want to know, does this have translational symmetry? So translational symmetry is if you take the image and shift it, will we get the same image? If we get the same image, if I took one of these and shifted it up? Yes. So this has translational symmetry. That's all you need with a yes. On 58. Again, anytime we talk about symmetry, remember we're saying the figure gets mapped onto itself. Those are keywords to look for in answers. So actually, let me write one extra thing here. Yes. It is mapped onto itself. All right. On this one, same thing, rotational symmetry. So can we spin it and get it to map onto itself? Again, the answer is yes, but there are 3 answers that say yes. So, was it sign up? Okay. So there are 3 answers that are yes, but there's a difference in them. They also want us to identify the order. The order is the number of times we can rotate and get that same image. How many times can we rotate that and get the same image? 4. 4 times. So the correct answer here is B. Now, notice how so the order here is 4. If they had asked us for the magnitude or the angle of rotational symmetry, what would that be? So how many degrees are in a full circle or full rotation? That's 90. 360 is all the way around. So if they ask us for an angle of rotational symmetry or the magnitude, we have to take 360 and divide by the order so that our angle of rotational symmetry is 90. Again, just throwing it out there. I didn't see it on the exam review anywhere. Just want to make sure I go over it in case they, for some reason, have that on the exam. Questions there? All right. 59. Can I get rid of this? All right. Good. All right. So clearing this off, we got got on number 59, which is at the top of the next page, got some directions that tell us this point is being first reflected over this line. So again, count your spaces. Here we have 4 units from there to there. So going 4 units over, it's now here, right? Then we're reflecting across this line. So we have to go perpendicular to that line. And we have to go the same distance away. So this is where our point ends up. Where is that point? It's at 4, positive 1, 4, 1. That's our coordinate point. Answer is D. On 60. This is one of those ones where if you just did it on your paper, drew the image, you could probably figure this one out pretty fast. So if I drew this out and just saw, all right, I have these coordinates. Oh, look, all 4 of these have the figure in a different quadrant. Here it's in quadrant 4, or this one's in quadrant 3, this one's in 1, and this one's in 2, right? So if I know where this image starts off, this image currently, A, B, and C, all have values that start off down here in quadrant 4, right? So again, that's the quadrant I'm starting. It says that we're reflecting in the Y, so I would go from here across the Y, and I'd be over here for my next image. From there, it says I'm rotating it 270 degrees counterclockwise. So that'd be all the way around counterclockwise. It'd end up over here in quadrant 2. So D is our correct answer. I didn't even have to actually do the problem. So again, remember, sometimes it's easier just to draw it and figure it out that way. All right. Now, if you did want to take one of the points like I did on the last example that was similar to this, you take one of those points and do those 2 transformations and figure out if the point was good. So, for example, if I took A, which was at 3, -5, and did the 2 transformations to A, reflected in the y-axis, that would change the y value. I said x-axis. I meant it says y-axis, so that's changing our x value. We have -3, -5, and then a rotation of 270. That's switching them and changing the original x. So we're going to switch these 2 around. So now -5 is over here. The original x, which is -3, will come over here and change signs and become positive. So we have -5, 3. -5, 3 is in our second quadrant. So again, over here, look, there's A double prime at -5, 3. So 2 different ways to do that problem. Whether you're using your rules or you're just drawing a diagram, they both work. All right, on 61, they gave you an image. Again, we can do a rough sketch on this. So I would do the same type of thing that we just did on the last one. We have the figure drawn down there in quadrant 4. First, they say they are going to reflect it on the x-axis. So, reflected up here. It looks something like, that's not perfect, but it looks something like that, reflected in the x. And then, translated 4 units left. So then we go over here. 1, 2, 3, 4. It'll end up somewhere like this, maybe. Again, not perfect, but this would be our final image over here. There it is. It's figure A. On 62, they gave us the original points, and then they want to know which one of our images shows the correct original ABC and A double prime, B double prime, C double prime. So it says it was reflected across the the y-axis and then the x-axis. So if we start off with an image here like this and reflected across the one axis, it would end up looking something like that. Then reflected down, we end up with an image that looks like that. So B is correct. Again, starting there, reflecting and reflecting again. It should be in quadrant 4, and it should be facing that direction. Now, could you just use the quadrants at this time? Now you can see also had a quadrant 4, so we had to look at the image, see what way it's going to face. D was our answer. All right, 63. 63. We have which congruency transformation maps it onto itself. Now, it does say select all that apply, so there's more than one that works. Anybody want to take a guess as to which two works here? A and B. One says reflect over y and then over x. The other one says reflect over x and then over y. It doesn't matter. If you're reflecting over both axes, you're going to end up in the same place at the end. That's just like the last problem, right? Reflected over those two axes, it ended up in that opposite quadrant. All right, on 64, looking at the image, which one is congruent to the token that's there? Well, notice the plus sign and the dots are diagonal from each other there. So the only one that shows us an image with a diagonal is C. So C must be our answer. Questions there? All right, let's go on to 65. On this one, consider triangle ABC has been transformed through rigid motions. All right. So they want to know which one of these conclusions can be drawn based on the given information. So look at this first one. They tell us all three angles are congruent. So that'd be AAA. Does AAA work as a congruency statement? Does it? All three angles? No. All three angles tell us similarity. Does not tell us congruency. So that one's false. The next one. I didn't even draw the triangle the first one. I knew they had all angles. This one, again, they gave us two angles and a side. Well, there's two possibilities with two angles and a side. AAS or ASA. Do I really have to draw a picture to identify which one it is? Not really, because both of those are acceptable. So no matter what, if I have two angles and a side, I have enough information. So that one's definitely true. The next one. This time I have two sides and an angle. So two sides and an angle could either be SSA or SAS. Well, if it's SAS, it would work. If it's SSA, it doesn't. So I need to draw an image this time and see which one is it. So let's draw the figure. I have triangle. I'm just going to draw one of them. A, B, C. So we have A is one of the angles we're using. We have AB is one of the sides we're using. And BC is one of the sides we're using. So we have two sides and the angle that's not included. So it's SSA. Does SSA work? No, it does not. So this is false. Again, the only way that would work is if it's a right triangle and it doesn't give us information to say it's a right triangle, so we can't use HL. Do you need another copy? Like 3/4 of the way through. We're at 66 now. Yeah, that's the number. All right, so we have triangle JKL is reflected across x equals 0. First thing, if they tell you x equals 0, that's the same thing as the y-axis. Remember, it's kind of opposite. X equals 0 is the y-axis. Y equals 0 is the x-axis. They could use those names instead. Now, was that important for this problem? No. What they're asking us is, do we have congruent figures? Well, we're doing a reflection and we're doing a translation, both of which are considered congruent transformations or rigid motion. So if we do two rigid motions, is the first and final image going to be congruent? Yeah, because if you do a series of rigid motions, oh, I can't think of the word. It starts with a C. You do more than one. It's a composition. A composition of rigid motions still gives us rigid motion. So on here, only answer that says yes is C. So that'd be our answer. All right. Questions there? All right. She just went, so when she comes back. All right, clear that off. On to the next one. So 67. 67, describe a similarity transformation that maps the smaller triangle onto the larger triangle. There are two ways that you could do this, but first thing, this is a small triangle, that's a big triangle. So it has a change in size. A change in size is what type of transformation? A dilation. Now, how much did it dilate by? Well, if you look at the length of this side is 1 unit long. This side is 3 units long. So what would we have to multiply 1 by to get 3? 3. So this is dilated by a scale factor of 3. Dilated by 3. That's the first thing. So now let me draw that image, because if I take each one of these points and multiply them by 3, I should get my new image. So this is at -2, 1. So multiply -2 by 3, multiply 1 by 3. We're now at -6, 2. Same thing over here. This is at -2, -6. And now we're at -1, -2, which is now at yes. I drew that one wrong. Let me fix that. I said this one correct and I drew it wrong. So multiply by 3, that's at 3, -6, -3 right there. All right, this one is at -3, -6 right there. The last point at -2 will now be at -6, -6 right there. So there's our figure after the first transformation with a dilation of 3. Now it's over here. How do we get that over here? Reflection. So this was reflected. Reflection in, this is our y-axis. That's it. Remember, it is a multiple choice test, so it should be there somewhere. How many questions is on this test? 15. 15 multiple choice questions. All right, on 68, we have which best describes this composition of transformations that maps these onto each other. Well, first off, there's a change in size. So what do we have to include? Definitely has to be a dilation. Now, do we get bigger or do we get smaller? So we went from this one to this one, got smaller. So an enlargement gets bigger, our scale factor has to be greater than 1. A reduction is making the image smaller. The number has to be between 0 and 1. So we have a fraction. So looking at these, A and C are out because they use a scale factor of 3. Here we have a scale factor of 1/3. Those can work. Now, we don't know if we're doing it first or second yet, but what's the other one that we have? We have a reflection and we have a translation. Well, in a reflection, the order of these is going to change, right? And in translation, they have to stay the same. So without even doing much work, is this currently in the same order as this one? No. So this can't be a translation because the order would have stayed the same. So I know this one's out. The only one that could possibly work is this first one. You want to try it out? Try it. We have a reflection in the line N. Well, N is right here. So we reflect it. We get this. This would be now L. Whoops. That's a prime. You know that. M prime, K prime, and this would be J prime. All right. So we have that. And then we have a dilation. Bring it back towards our mark there. Those all line up nicely with each other in 0. So, yep, it works. There's a reflection followed by a dilation. was B. Then you have 69. You're good? 69 okay, this one's a little bit confusing. A weighted average. All right, very small piece that they asked a question on this. I'll be surprised, but they have another review packet, so we'll talk about it. The coordinate 3 has a weight of 1. The coordinate 5 has a weight of 3. The coordinate 9 has a weight of 2. Find the weighted average. Two different ways that you could do this problem. Multiply each of those weights. 3 times 1 equals 3. Then we have 5 times 3 equals 15. Or we have 9 times 2 equals 18. Add those up and add the weights up. Adding those up, that is a total of 36. Adding those up, that's a total of 6. Get the weighted average, have the overall total, 6, divided by the weight, and we get 6. The other way that you can do this is do them each as a separate number. So you have a coordinate 3 has a weight of 1, so there's 1 3. You have 5 has a weight of 3, so you have 5 3. So 3 plus 5 plus 5 plus 5 plus 9 plus 9 divided by 6. Yeah, same thing. 36. Huh? Bathroom, yeah, she came back and she's out. So
She's been out for like 10 minutes.
No, I think she's been out for like 2 problems so far, but she just came back. So she's not back by the time I get to 72. Then I'll go. All right. On this next one, the chart shows weights and assignments. So again, another type of weight average thing. Multiplying by the percent and then adding them all up. So I got this 95. I'm going to multiply these. And instead of having to redivide it in, I'm just going to multiply by this one as like a decimal. So 0.10, 0.20, 0.30, 0.40, and so on. So 10% of 95 is going to be, whoa. I just did that wrong. Yeah, my eraser. Okay. 10% of 95 is 9.5. All right. 20% of 75 is 15. 30% of 85 is 25.5. And then 40% of 90 is 36. Add them all up. So those are going to round up the next value. That gives us 26, 32. Add those up. That's 8. So it's 86. All right, 71. All right, classify the triangle. Now, at first glance, we only have 3 options, right? This one is either going to be scalene, isosceles, or equilateral. All right. Does it look like all 3 sides are equal? No. Definitely not, right? This side is way shorter than these other 2. So right away, I can cross off equilateral. Doesn't work. What about these other 2 sides, though? This image could be off a little bit. I think they don't look the same, but if the image is off by just a little bit, they're close. So we really should probably check them, right? So if they're congruent, it'll be isosceles. If they're not congruent, they'll be scalene. Right now, I think it's scalene. But let's plug it in. How do we check it? Distance formula. We need to find the length of those 2 sides. Again, distance formula. distance equals the square root of x2 minus x1 squared, plus y2 minus y1 squared. So, doing AC first, we have D for AC equals the square root of, I'm going to use this as x2, y2, so use those coordinates first each time. I have 8 minus negative 5 squared plus 6 minus 1 squared. Well, minus and negative becomes adding a positive. So this is actually 8 plus 5, which is going to be what? 8 plus 5 is going to be 13. 6 minus 1, that's going to be 5. So now, whoops, 13 squared, that's 169. 5 squared, 25. For a total of, still on the right one. 194. All right. Do I really need to do the square root? We can compare. So we just need to see if it's the same as the other one. So the other one we're doing is AB. So we have, again, I'm going to use that as my second value each time. Start it off. 8 minus 2 squared plus 6 minus negative 5 squared. 8 minus 2 is 6. 6 squared. 6 minus negative 5, again, that becomes plus 5, so that's 11. So now we have 6 squared is 36. 11 squared is 121. Add them together and we get 157. Are they the same? No. So it is scaling. All right, all the sides are different, therefore it's scaling. All right, 72. The boss hands you a piece of graph paper that shows the plans for a truss. Your boss asks you if you can prove that DBE is congruent to FCE. It says hint, use the distance formula. All right, so can we show that they are congruent? Where is it? DBE. So we're looking at this triangle and this triangle. All right, and we're trying to show that they're congruent. So we have to check the length of those sides. All right. Well, this length is the easy one. This one's 1, 2, 3, 4, 5. This one's 1, 2, 3, 4, 5. Great. For the other side, we plug into our distance formula. Now, if this is a question on the actual test, remember, it's got to be multiple choice. So, are they going to ask you to write out this whole distance formula like that on this one? No. But if we wanted to, we do something like this. Are these the same length? Yeah. All right. This is, we have, you could use Pythagorean theorem. I like using Pythagorean theorem better. But if we're plugging into distance formula, the change in x and the change in y, that's what these two values are. So if I was doing distance for, say, dB, we would have the square root of, this is changing y is 3, x is 3, changing y is 3, so 3 squared and 3 squared, that's 9, plus 9, which is 18. We can then do the same thing for CF. The distance for CF. Do the same thing. And look, 3 by 3 are same values. So guess what? It is the same. 9 plus 9 is still 18. And again, we should do the same thing for the other one. But again, the dimensions are the same. Change of 2, change of 3, change of 2, change of 3. We're putting the same numbers in every time. So yes. All right, they are congruent. All right, going down to 73. Oh, and you should say, how do you know they're congruent? So I'm able to use distance formula. So yes, they're congruent by SSS. All right. Okay. On 73. Wrong button again. '73. You correctly found the distance between these 2 points. Great. You made your mistake in what step? Oh, sorry, you incorrectly found the distance between those 2 points. Where did you make a mistake? So look at the distance formula. I just wrote it down a second ago. Is the distance formula correct? Looks good, right? You have the square root of x2 minus x1 squared plus y2 minus y1 squared. So I think we're getting step 1. So I'm going to go ahead and cross that one off. Then we plug in the values. All right. Well, they got 0 here, so they use that as x2. They got -2 here, so they use that as x1. Then they have 3 plugged in, so this is y2. And then they have, wait, what are they plugging here? They plug in a +3 again. Do I have 2 +3s?
No.
No, this one was a -3. If I plug in -3, that should have ended up being positive. So there's my mistake. It's in step number 2. On 74, what is the distance between -5, 2, and -9, -4? The easier answer in simplest radical form. I don't know why I did say that, because simplifying is not until semester 2. But we'll do this real quick. So again, plug it in. We have -9 minus -5 squared plus -4 minus 2 squared. That's with adding, so that's now a -4 squared. This is going to give us -6 squared. -4 squared is 16. -6 squared is 36. Add them together, that's 52. Now, this is where we really shouldn't have done this yet, because we get into the simplifying of radicals in the second semester. Not saying you haven't done it in algebra before, but we have biggest perfect square that goes into 52 is going to be 4. Why is that biggest perfect square? So, like your perfect, well, I didn't do it right. 2. Our biggest perfect squares. So one squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So on, right? So those are our squares. In order to simplify a radical, you can take out any perfect square. Well, the biggest perfect square that goes into 52 is 4. 4 times 13 gives us 52. We can do the square root of 4. Square root of 4 is 2. That's 2 square root of 13. That one can't be reduced. That'd be our final answer. Now, if they did give you something like that on the test where it's at its simplest form radical, find your answer, put it as a decimal. Look at your answers and plug them into your calculator and see which one makes the same decimal. All right. Again, it is multiple choice. On 75, the endpoints of AB are, and they give us 2 endpoints. Find the coordinates of the midpoint. Plug into our midpoint formula, which is taking the average of the x's and the average of the y's. Again, midpoint formula. X1 plus x2 divided by 2. Y1 plus y2 divided by 2. So we have 2 plus -4 divided by 2. We have 5 plus 7 divided by 2. 2 plus -4 is 2. 5 plus 7, that's going to be 12. -2 divided by 2 is -1. 12 divided by 2 is 6. So our coordinate point is going to be at 1,6. Or sorry, -1,6. On 76, if AB has endpoint at 2, 13, and midpoint at 10, -1, give the coordinate of B. So, I know, you complained about the last person. That's like
Huh?
10 times more.
It didn't take me long. I left at 12.
What number was I on when you left? You remember?
70. You're on 73.
I'm on 76.
Oh,
Yeah. That's at least 12 minutes, probably.
no, it was
It was
I
about
left
2
at
minutes per
12.
question.
I left at 12. And plus, the bathroom, like, it's pee on the floor. So I had to go to the other one.
All right. On 76, if AB has endpoint 2, 13, and midpoint, give the point of B. This is where I like to use snowman method. Take the endpoint, the midpoint, and the other endpoint, stack them. We have an endpoint at 2, 13. We have the midpoint at 10, -1. Look at the difference. So the difference between 2 and 10 is +8. So if you 8 more, we're at 18. 13 and -1, the difference there is -14. Do -14 again, and we're at -15. So 18, -15 is our answer. All right. Stop there.
Wait, why'd you go right there?
Sorry.
Okay, I got it right.
I will post it.